to our Women in Software Engineering Lunch and Learn event. For anyone that's kind of new to the events, Women in Tech is a Third Republic employee-led effort, and we try to kind of challenge the gender imbalance that exists, I suppose, in the tech industry. As part of this, our mission is to kind of inspire and develop the careers of female technologists by putting on events like this one and our panel events as well, and just giving women and everyone, I suppose, in tech the chance to kind of learn from each other and share experiences and things like that. So yeah, we've got a real vision to kind of empower the community and along with everyone here, be kind of change agents in the world of tech. This afternoon, we're joined by software engineer Katie Walker, who will be speaking about and demoing all about debugging the web. Without further ado, Katie, I'll hand over to you.
Hey everyone, I'm Katie. I'm a software engineer. I've been an engineer for I think about 2 years now, so still fairly new to tech, I guess. For some background, I worked at Capital One for a couple of years doing a mixture of web development, and then I did some back-end service development, so that was more with Java and that kind of thing. And now I'm a full stack developer using JavaScript for everything. So that's, I guess, kind of my background and why I'm interested, I guess, in the web. So kind of an intro. I find that debugging the web applications can be a real pain sometimes. You know, as I worked with Java for a while, you know, you don't have that visual aspect that you do have with some web programming. So, you know, when you're making your like HTML components, you're going to know quite quickly that maybe there's something wrong. Like if your component is obviously looking pretty bad compared to what you want it to look like, you know, you're going to realize quite quickly. Whereas when you're doing, say, back-end work, it's a little bit more tricky to figure out that there are bugs. You need your unit tests and other kind of testing to help you with that. But you know, it just makes your life a little bit harder when you're doing it on the front end. So I think one part of that is definitely the lack of types. You know, with JavaScript, there aren't that kind of set types there are with other languages like Java. And sometimes you get this like weird mix of like front end and back end code, particularly things like frameworks like Gatsby and Next. They're all this kind of bit of a mixture nowadays of putting your basically your HTML views in your backend, or sometimes your like middleware code. I do think that good tests do help a lot. I'm definitely not advocating for you to not use tests by any means, but fortunately you are still going to run into bugs sometimes, and you're going to have to try and debug your code. So at the end of this talk, I kind of want to give you like an overview of some of the different methods of debugging that you can use and how you might use them in the best place. Hopefully I'll show you that with a little bit of time investment and a little bit of learning, your debugging methods will make your life a lot easier when you're hunting for bugs and trying to track down your problems. And also I'm hopefully going to provide some resource at the end that kind of will help you, I guess, have a go yourself. I'm going to try and make this more of like a demo than, you know, just a straight talk, but there's no way really of you to like follow along at like real time. It'd be well, pretty much. So, you know, you can go away afterwards and maybe have a practice based on these slides and the resources that I'm going to link. So the console log, if you've ever done some JavaScript work, you know that it's a very, very popular tool. I personally can't count the number of times that it's helped me either find bugs or just have a look at my code to understand a bit better how it's working. I have also committed it to master a few times, which is not ideal, particularly when you work in like a big corporation where there's like linting and things like that basically will mean your like code is going to fail, which is not great. I mean, it's great for keeping that kind of thing out of the code base, but yeah, it's still one of those things you have to kind of like be aware of all the time. So here's a really, really basic kind of use case of the console log. I've tried to make it like super simple, so hopefully you'll understand it whether you've seen JavaScript, or if you've not even seen JavaScript before, maybe you can kind of see the gist of what's happening. We've got this like little function where we're just doing some addition and then we're returning the result. In this case, I've just added a console log line to outputs the function called with some particular parameters. So in this case, we're just trying to add up 1, 2, and minus 3. And you can do that in your head. You're expecting that we get 0. So we run the code and we get 0. That's great. So a slightly more trickier problem. For whatever reason, maybe we're making a calculator app or something, and we want to use maybe this equation in our code. Okay, so this is a little bit more tricky than the simple addition. So a little bit more prone to like bugs and things. But yeah, so what we're going to do is we're going to like put this into JavaScript, and I guess just for visibility, like there is actually 2 answers to this, the way you have your like plus and minus, but for simplicity, we're just going to ignore one of the answers. So yeah, so what happens is this is what it looks like in code. I've just like typed it out, and this is where I'm going to show some code. So do shout up if you can't see the like text, or if it's like too small or a bit blurry or whatever. But hopefully you can see what's going on. So I pretty much just copied what was on the slide. We've got this like line 2 where we've got our equation, and then we're just going to return it. So in this case, what I've done is on like a separate calculator and on like an online quadratic equation solver, I've just put in these numbers, the 1, 2, and minus 3, and apparently we're expecting the answer 1. So that's cool. So what I'm going to do is I'm just going to run this, and okay, so we've got 6. So that's not ideal because there's obviously something gone wrong there. So what we might do if we were going to use console logs to debug this is we might try and split it up. So what's happened here is instead of having that one big long line of like everything happening at once, what I've done is I've just split out the different the different sections of the line onto its own like thing. So we've split out a little bit here, split out a little bit here. It's kind of hard, I guess, to see without the like the picture, but this is what it looks like split out. So what I've also done is comparing the like this, I've like written down kind of on a calculator how you would evaluate it. With like BODMAS, you might like do this bit first and then like evaluate this bit, and then once you've got that, you might put it over the 2A. So this is kind of how I've done that. So I've also added these little like specs just to make sure that we're like doing the right thing, and to hopefully see where our bug might be. So we're going to now run this one. So we can see straight away that this like chain of console logs that we're expecting doesn't match what we're actually getting. So we can see quite quickly that there's something wrong. Obviously we know that. And it looks like that because we've got this expect 4, but straight away we're getting 14, we're probably going to have the problem, or a problem at least, on this line. So, you kind of look at this and maybe write down what you're expecting and how you did it like step by step on paper. And basically what it looks like is happening is we put the bracket in the wrong place. So in the like original equation, this like square root is supposed to be around the b squared 2 minus 4a. Actually, what I've done is I've made a mistake here and I've only square rooted the b to the power of 2. So if we put that in there, and then we try run it, hopefully, great. So we know we're expecting 1, and now we've got it 1. So what we might do next is put it all back together. So we've kind of got, this is just the original equation, and now we know what is wrong. So we can just like, do this little move around. And I'll just run this one as well. We know that if we slowly started putting this back together, we would get the right result. So this is just kind of copying what I've done. In general, we saw quite quickly there that we had some pros of doing it that way. So we didn't have to use any imports or libraries. It was pretty minimal what we need to add to actually do the debugging. We just added some console logs on each of the lines. It was quite intuitive, I guess, and just sticking a console log wherever you want to output something. And there are actually some more console functions that you can use. It's not just the logging, which is quite useful for different kind of scenarios. You might want to use them. However, it wasn't very efficient. We did have to split out our like long line into lots of different sections, which wasn't exactly the quickest. Obviously I did it kind of before this talk, but if you were doing it real time, it might take you a few minutes to do that. It could be tedious as well to output a lot of information. You know, that was only one kind of medium complexity equation. If you had a really, really complex one, it could take a long time for you to figure out what the problem was. And you also need to do the cleaning up afterwards. You know, if you want to get rid of those console logs because you don't want to actually add them to the code long term, you need to go through and like tidy them all up, which sometimes you will miss them, especially if you've got like lots of files open and you're doing it in lots of different files. You're going to have that risk of maybe forgetting one or two. So some more kind of examples of like the console functions that you can use. There is this concept of a trace. If you're familiar with like exceptions and how, you know, if you get a bug in your code, it will probably throw an exception. You get like a trace log to help you track down where that bug actually is. This is kind of like that, but you don't need that original bug to like cause it. So it's more of a help you understand your code rather than help you fix the bug, because if there was a bug, there'd already be a trace, if you know what I mean. But as you can see, we've just run this code. And what happens is, you know, it's doing this slightly over complicated for this particular example, but maybe your code is quite spaghetti-like and you've got lots of different functions and lots of different files. It's doing this add item, and then it's doing this add tax, and then it's doing this get tax. And you can see this trace here is like basically like a backwards in order of like the function calls. So we can see that we started with get item or add item, sorry, we add tax, we get tax. So yeah, it's one of those things that if you did want to maybe track down how your code was working, this would be a really good example. And then we've got console assert, which is like a think of it as like a really basic unit test. So we can see here that we're doing this add item call where we're doing subtotal plus item cost. So in this case, you know, we're expecting it's going to be 12. What we can do is actually this assert, and we know that, you know, this is going to fail, but you could add this in your code to maybe check that. Yeah, just to check that something is working as expected, because I think what happens with VS Code, maybe some other IDEs, is if yeah, so if it doesn't fail, it doesn't actually output. So it could be quite a nice thing to add in your code base. You know, if you wanted a really basic unit test that in theory shouldn't output anything unless it does fail. And then there's also this console.time, which is a very basic kind of idea of a performance test. We can go to the time here, and you can see we've got this console.time, which basically is like starting the timer. We've got this useless loop here, but obviously you could add whatever you wanted to this. And then we've got this time end. And what happens if you run this is you can see that we get this loop time, and it just kind of tells you how long it took to run the code, which, you know, as our code wasn't really actually doing anything. It was quite quick, but maybe if you wanted to call some like APIs, or you're doing something that was a little bit more like CPU intensive and it was going to take like 10 seconds, 15 seconds, you might want to track that, because obviously the longer it takes, it might affect your users, and that's not great. So there's that one. So those are kind of the main console functions, and kind of, I guess, the pros and cons of them. What I also like to do is use VS Code directly by doing your debugging. So I've got some screenshots, but I'm actually going to show like a demo. So how we, I guess, start debugging with VS Code is to go over to this little like debug icon with a little bug. And what we can do is open this debug terminal. And what it kind of does is, you can see that this ZSH, that is my original console terminal, whatever you want to call it. And then there's this debug terminal. So once we're in here, this is where we can start to do our debugging with VS Code. And how it works is, first we have to be in the right code. And we can run our files. So in this case, let me just put this back. Okay, so we've got this simple like solve function again, and we can run it with our new debug terminal. So we run this. It's actually not going to do anything at the moment because I mean, we've got this console log which is outputting, but it's not going to like pause at any point, and that's because we haven't added any breakpoints yet. So what we can do is, using this like debug terminal, we can start to add breakpoints. So maybe there's a point in your code where you want to try and see what's going on, or you've got a bug, whatnot. You can actually add in a breakpoint. So I'm just going to put one here, so on line 3. And now I'm going to try and run the code again. I'll actually get rid of this console log because we don't need this anymore. And we'll run that. So you can see actually what's happened is we've got this like orange bar, which I guess signifies that we're in the debug like mode. You actually see the code has paused on line 3. That's because I've added the breakpoint now. So what we can actually see on the left here is the different variables that are kind of in memory at the moment. So we can see that our A is 1, B is 2, C is -3, and that's obviously correct. We've called the function with these different variables, so that's great. Total is undefined at the moment, and that's because this line is still being executed. If we do this little step over, click, we can like jump to the next line. So you can see now that total has been assigned, which is great. So, you know, if you maybe had a bug here, or if we went back to that original idea, you could see at which point actually was causing the problem, because you could see the variables at each point, which is pretty cool. And there are some other kind of tools here, which it's kind of one of those things you just need to practice, I would say. So we've got this like continue button, which will effectively continue the execution until, say, maybe the next breakpoint. So if you had like, what could we do here? Let's get rid of C. We'll do, change that from a const so we can change it. So we'll just, so this is like the exit button and such. So it's like stop the whole debugging mode. Maybe if you found your bug or you're just completely done, you can just come out. So what we can do here is make sure I haven't made a mistake. So we can put maybe a breakpoint there, and then maybe a breakpoint there. And then when we run the code, you can see that it's stopped on line 3. If we hit play, it's going to jump straight to line 5. So of course, if you had like hundreds of files, you might not want to have to like click through line by line. So that's quite a good way of doing it. This is like a step in function. So if we had if we had like a function call here, so maybe we do like just call it function. Obviously I've not defined this yet, so it's not going to do anything, but you can, I don't think it's going to build, so I don't know if I can actually demo this, but okay, we'll get there. So what you actually do here is you could click this little like down arrow, and it would try and jump into this function, which in this case is going to fail, it's not defined. But in some cases, you might not actually care like about the specifics of func, so you can just kind of step over it. Okay, well, it's failed in this case because it's thrown an exception. But yeah, you can know, obviously, if you did implement that, that would work fine. And this is just like a, I guess the opposite of stepping in. If you're in a function call and you don't care about it anymore, you can step out. And there's also this like restart. So yeah, it's quite easy. I think it takes a little bit of navigation, especially when you are using the like stepping in, stepping out. There are times where you kind of get stuck in a function. You're like, oh, I wish I hadn't done that. So it does take a little bit of practice, but yeah, as you can see that you've got access to your like variables, and you could like step through it and see exactly how the code is running at each point, which is really useful. I just think it's quite a nice experience. So I guess I could quickly go through these. This is just how you set it up, kind of what I've just shown. You can add breakpoints. You can then trigger the breakpoints. So in my example, I've been using Node to run all of my JavaScript files rather than like running them in a browser or in the DOM. So personal preference, you could use, I guess, other methods of running your JavaScript, but Node is quite a useful one just for running like the odd file rather than trying to build like a website. So we added our breakpoints, and then one other thing we can do, which is quite nice, is if we have tests set up. Let me find where they are. So So in this case, I've just written a really small unit test. This is using Jest. Clear that. And okay, so we have to do a little bit of kind of tweaking, but what we can do here is we can get rid of this now because we don't need it, which I guess mimics what you might have in a real production app. You're not going to have just random like top level function calls. What we do need to do is we need to add this module exports here so that this solve function is accessible outside of the file. Otherwise, if we ran this test, it would say that solve just doesn't exist. But as you can see here, we just imported it and it can find it because this is getting exported. So how we can do this is we can just use Jest, which is quite a good JavaScript testing package. And we can run our test. And what's happened here is we're still running in the debug terminal and we've still got our breakpoint. So it means that the test is paused, which is, again, good if you want to try and debug. Just like before, you can like step through the code and see how total's changing. So at the moment, it's just been set to 3. And it's going to fail again because we've got to get rid of the function. Let's just change that to C. Let's try run the test again. Yeah, okay, so we've got our total, and then on line 4, we're going to add -3, I think. Yes, the test is -3, so that's going to go, I guess, back to 0. And then if we just keep going, you can see that it's now doing this assertion. It's saying, you know, do we expect result to equal 0? Hopefully it's going to, okay, this is where it gets a bit deep. We just kind of continue from there, and you can see our test is passed, so that's great. So it's just another way of, I guess, triggering that breakpoint, because you do need some way of triggering a breakpoint when you add them. There we go, that was using our tests. So I guess overall, the pros of using VS Code for debugging, I think stepping through gives you lots of clarity. As you can see, we could go through line by line. We can see exactly what the variables were at each point. We could see when things were being evaluated. It just really shows you exactly what's going on because you can see every single point. It doesn't require any code that you need to get rid of afterwards, like you did with the console logs. I guess the caveat here is, obviously I needed to add that Jest test if I wanted to use a test. But I would say, like, long term, if you're going to be building an app, unit tests are only a good thing. So that kind of thing you want to leave in the code, and maybe you could write more tests later on. So I don't think you need to get rid of it by any means. And I do think also your code looks the most familiar in your IDE. There's times where I've like changed my color scheme, and I feel like my code just looks a little bit different. I don't know if it's just me, but it just feels a bit off, and I have to like refamiliarize myself with some of the code. So I think being able to debug in the IDE is really great in that respect. So the cons, there are cons as well. You do need a way to trigger the code, which if you're like a beginner programmer, might feel a little bit of a weird concept. And also it might need some refactoring. You know, I did need to add that module exports to make sure that our function was accessible in our test. I do find there are sometimes limitations, either with particular libraries or test runners. There are times with Jest that I found a few problems have cropped up if I'm trying to do like watching the tests. So there's kind of a concept of you can set Jest up to watch a file. So when that you save like a test file, it will rerun all the tests. Sometimes I found the breakpoints, they go a little bit weird in that instance. And libraries. So libraries like Next.js, which the way they render the code can be a little bit weird, and trying to get that to work sometimes with breakpoints can be a little bit tricky. So we can also debug with the browser. So it's kind of a similar concept, to be fair, of what we did in VS Code. You know, there is definitely a familiar concept across like all IDEs, most browsers, things like that. So once you have had a practice with one, they're quite familiar, to be honest. So with Chrome tools, it is, I guess, looks a little bit different because it's in a different area, but there's still like concept of like adding breakpoints and things. So what we can do here is, I've just got my website up. It's a really simple static website. We can just go into inspect. And if you're not familiar with this, this is like a way you can see all of the like elements on a page and like all the text content and things like that. What we can actually do here is we can go over to sources, and I don't think it looks like this when we start. Let's just minimize all of these and get rid of that, so I guess it looks most accurate. What we can do actually here now is look through the files. So it can be a little bit tricky at first to find like which one you actually need, but what we're going to do is just kind of a little dig and see if we can find the right files. So here we go. So this looks, I guess if you're familiar with React, this will look pretty standard. It's just like a really simple way of setting up your app. So in here we've got the app, which is like the main component that contains things like the meta information. And sorry, I'm just realized this might be quite small. Yeah, it's just kind of all the root stuff. This was quite a quick website, so it's probably a bit of a mess to be fair, but it works. So what happens is you can just kind of look in here, and just like before, you can actually add breakpoints. So in this instance, I haven't got any like bugs to show, but what you can actually do is just add your breakpoint and then trigger it like you did with VS Code. So I quite like doing the like triggering in like the browser, because what you can actually do, it kind of makes sense, if you know what I mean. So if you have a piece of code that you know runs when the page loads for the first time, all you need to do to trigger the code is to refresh. So like, for example, this is like the root component. We've just got a bunch of stuff to do some color scheme things. If I add like a breakpoint here, and then I refresh the page, as you can see, my page hasn't loaded, and that's because the code has been paused, because this runs at like initial page load. So just like with VS Code, we can start to look at these variables at the side, which to be fair, don't really mean a whole lot at the moment. But we can also do the resume function. We can do the step over, the step in. There's also some extra things like deactivate the breakpoints. So if you've got like loads of breakpoints everywhere, you could just in theory click this and it would get rid of them all, which is quite neat. What we can do is we'll just do this like step over, where we just step over through the lines. And as you can see, as we're going through, these variables getting set, which is pretty cool. So yeah, all these lines are really doing is, I think they're looking like my local storage to see if I've set my, if my color scheme is set to dark mode. And if it is, I want the website to load in dark mode, and obviously if it's in light mode, it'll load in light mode. But yeah, you can just kind of see that. You can go through and you can see what like all the different variables are, and I mean, state hasn't been defined yet because it's still being executed. But this this theme here, you can see that it's dark, and I think it's also, yeah, it's also over here as well. So I can go, I guess I'll just show you what happens when you like resume. It eventually will actually load the page. So kind of another example would be this toggle theme. This doesn't run at page load. This function is toggled when you hit this little toggle switch. So what we could do here is we could add a breakpoint. Maybe in theory we had a bug here, and we wanted to find out like what was happening. You know, is this maybe backwards, or we got some kind of little bug there? So I'm going to get rid of that breakpoint, and then what we're going to do is, now we've got this breakpoint, we can trigger it. So if we trigger that, you can see we've paused again, and this line has come up, so we can start to see like what's going on. You know, toggle, maybe this is backwards. You know, because this function is called by a few like nested functions, so there's always a chance that a bug might come in. But you can, yeah, you can kind of see how you might start to debug and see like what's going wrong and where. So yeah, these next few slides are kind of what I've just showed. How you like add breakpoints, how you do all the stepping through, and seeing how variables look and things. So overall, I think the pros really are like, it's super easy to trigger the code because you know kind of, I guess, exactly where that code is triggered in your code. I mean, it's getting a bit deep here, but you know, you're probably gonna have an idea of how you built the app, and if you click a button, is it going to run the code? Is this going to trigger this, whatnot? And of course, you know, if you've made your app really complicated, or you're picking up a new app for the first time, that might be a little bit tricky, but generally you're going to have an idea of where that code is triggered for. It's quite easy to see state. So if you're using things like React that do have a state, you can see that quite easily at the side. see variables, and just like the other debuggers, you can step through your code and see them at different points. And it's also quite cool that you can use it across the browsers, and it's like pretty much the same. I think like I use Firefox as my main browser, and it's called something slightly different, but otherwise like it's exactly the same. You know, once you learn the concept of stepping over code and stepping through code and adding breakpoints, like you're pretty much set on most of the browsers. The cons. So I do find that sometimes the bundled code is much harder to work with. I think if we tried to debug my like production version of the app we just looked at, because this is like a locally running server at the moment, none of this code has been bundled or compiled. It's going to be a lot more tricky to do it with something that has been bundled and compiled and maybe minified. You know, trying to step through that code would be very difficult, because in some instances it might just be like one long line like for the whole app, so it can get a little bit messy in that respect. I do also think the interface is a little bit cluttered. There is quite a lot going on with the browser versions of like the debugger. And if you don't know where you're looking, it can be quite tricky to see like what you actually need to see. So in this sense, like it's not too bad because I have minimized a lot of these, but I think some of these can get quite like in depth, which if you're just trying to like do some really kind of high level debugging, like this kind of event listener things. And I think actually if we try reload actually. On that. So you can see here, like we've got all of this call stack, which again, if you have maybe a problem that gets to this like level of depth, this is probably really useful. But for like the average person, this is quite a lot. And obviously this is like way into React world, which most people don't understand. So it can be a little bit overwhelming in that respect. So in conclusion, I do think that adding select unit tests to your apps will help avoid like most of the issues, but there are always going to be times that unfortunately, like even in your like smallest functions, there's going to be a bug and you're going to have to try and find out what that bug is caused by. Console logs, they're really popular. I love console logs. I still use console logs quite a lot. They are really good in a pinch, but they do take a little bit of time to implement and also remove afterwards and tidy up. And stepping through your code in, obviously it doesn't have to be VS Code, it can be any IDE, but something like VS Code or the browser can be a little bit fiddly and you have to kind of know where to look. I do think it needs a little bit of practice, but I do find it is also more effective usually, and you'll be able to see a lot more information a lot more quickly than something like console logs. So I've just added a couple of resources. I think that second one is kind of what I talked about today. You know, it's got both Visual Studio Code and Chrome, which yeah, is pretty much what my demo was. So I think it's fairly similar. And the top log was really good at getting started with like the dev tools and stepping through code and whatnot using Chrome. So thank you very much. I hope you found it useful. I guess shout if you've got any questions.
Thanks, Katie. I think everyone will agree that was really really insightful, really useful. We do actually have one question in the chat from Kat. She says, do you have an actual workflow to get Node to run a file, or is it just a case of having it installed?
Yeah, so it depends what your code base looks like. If you've got like a massive code base and you just want to try and run one file, like it's going to be a little bit tricky. For like my example, I had like just individual JavaScript files, so you can just use Node like directly on that file and it will run it. Which works really well, but yeah, it definitely doesn't always work like that.
What would you say is probably like the most challenging part of your job?
I think for me, like debugging is honestly one of the most tricky points. There's times where you get stuck on a bug for like hours and it can be really frustrating, and you sit there and you think, oh, why can't I do this? And you know, there's always going to be times I think where like it's beyond your knowledge and there's only so much you can kind of sit there and struggle for before you just, it would help so much more just to ask someone or like look online and that kind of thing.
Must be rewarding when you've been stuck on a bug for some time when you do get it though.
Yeah, definitely. It's I wouldn't say it's worth it, because it's obviously if you're wasting like hours and hours just sat there frustrated, but it definitely helps.
Yeah.
Do you have any resources or recommendations for how to learn React? I think for me, when I first started, like I watched loads of courses, and I think there's only so much you can learn from courses, to be honest. Like, I mean, personally for me anyway, I'm definitely someone who likes to kind of learn the basics, learn the theory, and then like try and build a like really small app. So things like to-do apps are quite popular, and yeah, just kind of put it to use, because then you actually figure out, okay, well, actually, how do I do this in React, and how do I do that in React? Which, if you just follow like a tutorial or a course, like you're not necessarily going to get that. So it's that kind of mixture, I think, of learning the basics from like a video or a blog, and then having a go at trying to implement it yourself for like an app that interests you as well. I think something that will keep you interested and make you like want to finish it and not kind of give up halfway through, which I think can be quite easy.
How do you keep yourself up to date with current tech?
Yeah, it's definitely a tricky one, I think, especially because there's just so much happening all of the time. I guess one thing I would say is like, don't try to keep up with everything, because you won't be able to, and you'll just stress yourself out. But I do think coming to events like this, I go to a lot of meetups and conferences and things that, you know, people talk about technologies and like frameworks and things that I've like sometimes never heard of, and you just kind of build up that like small amounts of knowledge, I guess. And obviously when you go to a conference, like I go to like JavaScript conferences because that's what I'm really into, and people talk about, you know, things that I've not really even considered, or like methods I've not considered, or things like that, and you just kind of learn something new, and people are always talking about like new frameworks and things, so that's a good way of kind of learning about them as well.
Thanks so much, Katie, for your talk. It was it was really useful and really helpful for everyone here.